answer. Very good. Okay, so it is a quantity that represents a magnitude and a direction. Okay?
I knew that. I knew it. Okay, fine, whatever. I knew that. Whatever.
I knew that.
I did though.
Sure, Brooks.
They all say. There it goes.
All right, so can somebody give me an example of where a vector would be used? Like a real world scenario.
Like the car was traveling west at 2 miles per hour.
Exactly. Okay, so a car traveling, what did you say?
West at 62 miles an hour.
West at 62 miles per hour. Okay, so the car has a speed, which is a magnitude, and a direction. You guys don't need to comment about everything. It'd be awesome if we could get through this.
What would north, south, west be?
Not.
Shut up. Oh my god. Alright.
Okay, so the first little section that you have to go through is simply going to ask you, can you use a vector to represent this scenario? Okay, so if you have a boat traveling at 15 miles an hour, why not?
Because there's no direction.
No direction. So we would say you could only use a scalar to represent this scenario. Okay, a scalar being just a single number, which is your 15.
So we need to know scalar.
Well, a scalar is just a single number, like 1. Right. Yeah. Okay, what about, how about a person's weight on a scale?
Yes.
Well, yeah, it's like a downward direction.
Ah, okay, so good. So weight we can use as a vector to represent it because if you're on a scale, if you're on a scale, let's say it pops out, you weigh 100 pounds. Okay, well the direction involved is what?
South. Down.
Down. Okay, so you have a downward force, which is simply gravity. Okay, so yes, we can use a vector in this scenario. Okay, so keep going, or do we understand when you can use vectors?
No.
Keep going?
I don't understand.
One more?
And you guys were in a class. Fine. Example
A
5.
child thrown upwards at 45 miles per hour.
Yes, you can.
Whoa, why'd you get to number 5?
Oh, because it's number 5 in my notes.
No, not a child thrown
I think
upwards.
that's
A child
what
thrown upwards. That's like 5'10". Child thrown. I'm not writing anymore. Child throwing. Salty. We gotta use a child that's thrown upwards.
Oh.
Yeah.
Okay, what about this scenario? If I have a child that's pulling a sled with a force of 40 newtons.
Yes, it says the word newtons.
Yeah, but what direction?
No.
South.
Newtons is simply a magnitude. Okay, so this one you could not use a vector. You could only use a scalar because there is no direction. It has to specifically give you a direction.
Or if there's a direction in it, if it doesn't have direction. So if it was a boat traveling at 15 miles an hour west, then it would be a vector.
Exactly.
Since there's no direction, it's
On the scale one, it basically the scale can only go up because you're pushing down. Okay.
Alright, so if you were going to draw a vector on a piece of paper, this is what it would look like.
Like a line.
Okay, so a vector starts at some initial point, which we can call tail. And it goes to some, let's say, terminal point, which I'm going to call the tip. Whoops. Okay, so basically what we are going to do in this particular assignment is we are kind of throwing numbers almost completely out the window, and instead we're going to be drawing lines. Okay, so we're going to try to make this quite simple. Alright, so let's say example 1. Okay, so let's say I have this vector A and a vector B. Okay, and we are simply going to add A plus B. Okay, so what I want you to understand about a vector, okay, is that, let's say my pencil is representing a pencil, or a vector. Stretch your mind. Okay, so this is a vector. Okay, so it has a magnitude. It is this long. And let's say I am going to keep it at a 45-degree angle always. Okay, so now a vector, I can take and move it around. Okay, it doesn't have to say it's going to start right at 0, 0 always. Okay, vectors can be moved in space. Does that make sense? Moved in space. Okay, so if I'm going to add A plus B, to draw this, I would start by drawing A. Okay, so it looks like this. Now, if I'm going to combine B, when adding, we're going to draw this tip to tail. Okay, so from the tip of my A, I'm going to start drawing my B. Okay, so this right here is the B.
You gotta move the letters. I cannot say.
What's the difference? There is no
Oh. Do you think A should go off of
Hey,
B?
it's her fault.
No, that's not it together. There's no difference, though, no. That's,
I mean, how am I supposed to understand A, B, tip, to tail all in one? Like,
so like, you have a vector, it's positive.
How does that look any different?
Well, it crossed over the words. Alright. Okay, come back. Focus. Okay, so now, the resultant. Okay, the resultant always starts from the very first initial spot. Okay, so my A plus B vector is going to be from my initial spot to the tip of my second. That's the resultant tail, or resultant vector, excuse me. Okay? Everybody good with that? Okay, so let's try a different one. Let's say we have...
Wait, you need to find the value of that?
Not yet. We will.
Oh, sweet. That's easy. I can draw lines.
Okay, so let's try this scenario. Let's say they have 3x minus 3/4 y. Okay, so let's say my x vector looks roughly like that. And my y vector is a nice long, kind of a 45-degree-ish vector. Nope, that's given. This is a given. They'll give you the vectors. So I haven't started anything yet. No, it's just given to you, but I'm going to get there. Okay, so if I have an x, how would I draw 3x?
3 of them.
I would draw 3 of
Oh,
them.
that's
Okay.
like representing 3x with that little line.
Oh. Okay, so this would be 1x. This would be 2x. And that's 3x. 3x.
So are they all specific?
they're gonna give you like the vectors, and you're just gonna draw them to the best of your ability. Okay, so they specifically say bring a ruler and a protractor, and we're gonna do it that way. But we're just gonna eyeball it, and I'm gonna show you with GeoGebra how to do it more exact. Okay.
How do you do in negative?
Okay, so good question. Now, if I have subtracting going on, how do I do subtracting? If adding was tip to tail, it's going to go tip to tip. Okay, so subtracting is tip to tip. Okay, subtracting is tip to tip. So imagine, you guys, turn around and focus. Okay, imagine that I take this y vector and put the tip so that it's at the end of my 3x. Okay, so when I draw it, it's going to look like this. There's my y. Okay, but if I'm going to draw 3/4 of y, what do I need to adjust? My length. So instead of drawing one full length of y, I can only draw 3/4 of it. Okay, so it's going to be a little shorter. And again, we're just kind of eyeballing this. Okay, so now where is my resultant vector going to go? Okay, so it goes from tail to tail, but which tail do I start at?
The initial tail.
The initial tail. So I start, exactly. I start at the initial.
So x is the vector and y is the vector.
No. It's 3 vectors.
No, but
Wait, why did you just drew a line there to connect?
From the initial to the tail of the other. It is 3/4.
Will it matter what
Sorry.
the
trying
side
to
the
make that
tip
look
goes
like
to? Does the tip always have to touch the tip of the y?
Yep. When subtracting, yes.
The tip always has to touch y?
Yep.
No,
It's going
okay,
to.
but I'm saying the blue line. Does it
Yes.
matter which end the tip starts?
Yeah, so you start, the initial starts at the initial spot you started at. And then you create the triangle, so you go to the tail of the Y. So you're drawing triangles. Alright, you guys ready for the next part? Okay, so the first thing that they kind of introduce with vectors is going to be bearings. Okay, so there's two different ways that you can measure bearings. Okay, so the first one is called quadrant bearing.
Does that say directional or
Directional. A directional measurement between 0 and 90 degrees east or west of the due north or the north-south side. So let's say if I have the bearing south 35 degrees east. Okay, so when it's in this quadrant bearing, the first piece will either be either north or south. Then it will give you your angle, which will only exist between 0 and 90 degrees. And the third piece is going to be either west or east.
Is this on a quadrant?
Yeah, a compass.
Yeah.
Mm-hmm. Okay, so here's our little compass. Okay, so my south is down, and if I'm going to go in the direction of 35 degrees, I'm going to start from straight down and go an angle of 35 degrees. Okay? It's not. It can't be a negative. It's only going to be between 0 and 90. Okay, so this angle right here is my 35 degrees.